Hello, you wonderful physics kids. Uh, we're going to be doing non-perpendicular vector addition. So get yourselves set. This is sort of a challenge, but it's really not too bad. I'm going to give you a method that works so extremely well, will guide you through it. The idea, we're going to take these two vectors. We're going to, number one, break into x and y components. Then we're going to add x and y components. Then we're going to construct new sum of x and y. That's it. That's all you're doing here. So let's take 8 newtons at 62 degrees and think about the xy axis here. Where is that going to be? What quadrant will that be in? Right? Well, it'll be in the first quadrant. Right? So this is 0 degrees up here, 90 degrees here, and so 62 degrees, we're going to be something like that. Okay, so that's 62 degrees. What is this angle going to be? We're going to need that angle, right? Well, it's going to be out of 90, so 90 minus 62, I think you get pretty quickly, is going to be 28 degrees. So this is 8 newtons, 28 degrees, right? With this method, every time we're doing this, we want to drop to the x-axis. So here's your vector coming up. And so we know this 8 Newton vector is made of your x sum and your y, rather than sum, your x vector and your y vector. It's the sum of these two vectors. So when you add x and y vectors together, you're getting this vector, 8 newtons at 62 degrees. That's a 62-degree rotation down from your 0 line. Makes sense out of it. So that's going to be vector number 1. Label it as such. All right, vector number 2 then, what quadrant is that going to be in? Well, 205, that's going to be a little past the 180 line, so we're going to want everything we're doing down in the third quadrant. First, second, third quadrant. So this is 180 degrees. 205 would be a 25-degree rotation away from that. Right? So that's going to be 25 degrees here. What's this measure going to be? Right? Well, that's going to be 65 degrees. Does that add up to 90 degrees? I think we got it. Right? Once again, now this is vector number 2, we're going to drop to the x-axis, right? And the vector is made of, notice it would have an arrow here. We'd be wrong in putting an arrow downward because this is going to be made of these two vectors. This one going this way, this vector coming up this way. So what is this? This is going to be a negative y value. This is going to be a negative x value. Over here, that x is positive, that y is positive. Okay, so that is our vectors. That's all we have to do here. Now, we want to make our table. This table is really how we solve this. It's all in the table. Right? X and Y. And when you make this table, leave plenty of room, at least 2 lines for vector 1, vector 2, however many vectors you're adding, and you can add as many vectors as you want. This is going to give you the totals. So for vector 1, the x value, we're going to use SOHCAHTOA. If you're uncertain at all, it really helps to write this. How would I do this? Well, for this measure, here's the hypotenuse, this is the opposite, this is the adjacent. All right? Well, I have the hypotenuse, I have the angle. For x, I'm looking for the adjacent. That would be the cosine function. So for number 1, just put down how you would get the x vector. And that would be cosine of 28 degrees times 8 newtons. Now, how do we get that? Well, look at this. Cosine of theta equals adjacent over the hypotenuse. So if I want adjacent by itself, I multiply both sides by the hypotenuse. And that's just what I've done here. So cosine of 28 degrees times 8 newtons. Now, is that positive or negative? Positive. Make sure you put that in. The nice part about this system is once you have that, over here, you're putting sine. The sine function always goes with the y, so the sine of 28 degrees times 8 newtons. Positive or negative? It's positive. All right, so down here, 65 degrees is the included angle here. To find Rx, that's going to be negative, and we're going to be doing cosine 65 degrees times, this is 6 newtons on this hypotenuse here, times 6 newtons. And that's the x. The y is also negative, so negative. That's going to be sine 65 degrees times 6 newtons. All right, so you look at this, we got everything we need here. And now just start solving. So I'm going to solve for all the x's. All right? Make sure your calculator is on degree. All right? Going to be important. Now here I could change that. Could go to radians. I want degrees. Now your calculator defaults 2 degrees, but if you have something other than that, it will not work very well. So 28, press cosine, times 8. All right, round to the nearest tenth, 7.1 newtons. That's positive. All right, now 65 cosine times 6. This is negative 2.5 newtons. So we can total these. So I'm going to have that negative 2.5 newtons, to which I'll add 7.1 newtons, and I will get 4.6 newtons. That's the total. So let's do the y. 28 sine times 8 equals, and this is going to be positive, 3.8 newtons. Down here, this one's going to be negative. We have 65 sine times 6 equals negative 5.4 newtons. All right, so I'll make that negative, and I'll add 3.8. I have negative 1.6 newtons. Well, now look at what I have. I have an x value and a y value. X value that's positive, y value that's negative. So that means the part of the xy axis that I'm going to be using will be down here, second quadrant. All right, so the x value coming over this way is 4.6 newtons. We go down 1.6 newtons. And notice how I'm vaguely scaling these. That'll help me if I make any serious mistake. All right, so we're going to be looking for this. This is going to be our resultant. And how do we find first the magnitude of it? Well, we're going to be squaring, we're going to be using Pythagorean theorem. So this squared plus that squared equals that. Take square root. Woohoo! So I could just take what's in here and square it. Plus 4.6 x squared equals, got to press equals, and then take the square root. And I get 4.9 newtons. Does that look right? Yes, that looks right. Right now we want to find this included angle theta. Now there's a special way to do that. This data and this data are the best data we have to do this. This is one more derived piece of data. So while this is still derived, it's still the freshest data we have. So we're going to use that. So which of the functions do we do for that? Sine, cosine, or tangent? Well, you can see tangent is opposite over adjacent. So opposite over adjacent, we're going to use that. Tangent of theta equals opposite 1.6 newtons over 4.6 newtons. Now, these are not negatives. We're just finding this angle. So it's just a straight up right triangle. No tricks. So 1.6 divided by 4.6 equals 0.0 yada yada. And then I'm going to do my inverse tangent. That comes out to 19 degrees. 19 degrees. Does that look right? Well, yeah, that looks right. Is that the final answer? Well, I certainly have 4.9 newtons at what degree measurement? Well, when we remember, this is 0 degrees here. So this is 90 degrees over here, and you have rotated an additional 19 degrees past your 90 mark. So that would be 109 degrees. And that, ladies and gentlemen, is how you do that. Non-perpendicular vector addition, the cool way. This table really makes it a lot easier. So when you just put in the data that you're going to then solve, before you solve it, you can check it. Cosine under the x, as long as you're always dropping to the x-axis, under the x values, you're always going to have cosine. Under the y values, you're always going to have sine. Gives you a chance to check whether it's positive or negative. Right? Both positives, both negatives. And so it lets you rise above your work, and you can kind of check your work and see if you're doing it right. This looks pretty good. So one more thing, please don't forget all your units. We do not ever have a number here without a unit. Nowhere should you ever see a number without a unit. You can see as a problem gets more complicated, you really want to keep track of all the units that you're using, every variable. We need to know which variable it is, and units always show us the way. Well, I hope that helped. Thank you for watching.